two.
I mean, like this.
Tires.
I don't want mine.
Exactly.
I have to put my truck up. I found a cheap lift kit.
There's a coil over it.
All right, for us to start off this afternoon, I need y'all to find handout number 45 that I gave to you after the quiz last time. Cole, that would be you. Okay, so we briefly talked about section or 4.8 last class. So it's mostly about finding sides and angles of right triangles, which you guys have been doing. We did the notes real quick, so I could remind you there is a geometry thing that's going to pop up randomly in a question that should help us out later. Also, we talked about something called bearings, which will be needed for a few of the harder questions. But what you should have done before you came to class was the rest of 1 through 15. So let me give you a chance to ask about any of those that may have given you trouble. Because if you're having trouble finding any of those with generic triangles, then that same thing is going to hold you back on the others. So let's clear that up, and then we will work through the rest of it. And again, this is all of 4.8 in front of you. And we have our 4.8 quiz next class. About half of the quiz will be like questions 1 through 15. About half of the points come from questions after 1 through 15. Okay. So, was there any of the first 15 that you needed help with?
Which one? Because my silence didn't add up. Or sorry, my angles.
Okay, so let's see. This is 25, this is 35, and so for your angles, we really have to give you at least one because you have to know it's the right triangle. To find angle A, you could do a sine equation. Sine of A is equal to opposite over hypotenuse. But if you want to know how big angle A is, that's when you use inverse functions. So regular sine, cosine, tangent for side lengths, inverse sine, inverse cosine, inverse tangent for angle measures. Also, I would be concerned if your calculator was in radian mode. If your calculator's in radian mode, it's going to give you a completely different number there. And then, in theory, you should be able to subtract these two from 180 to find the last one, but I'm going to just do a different equation for angle B. I will do inverse cosine of adjacent over hypotenuse. And then when I add those together, I get 180 degrees. Okay, did you find your mistake? Okay. Any others, 1 through 15? Yeah. 13? Okay, was it this part here? Okay, this is going to show up in a question or two later today, so I would totally understand why you guys may have forgotten this. We haven't done this in a while. But this is degrees, minutes, and seconds. So I've got 12 full degrees, and you have to remember that a minute is a 60th of a degree. That's the same thing that we did the first week of school. So when you put that in your calculator, you can change that to a decimal, and just think of it as 12.25 degrees. It's the same thing. Okay, and then if you need help with the other part, we can talk about that too if y'all need to, but I know that's a common one right here. Yes?
Could you do 14?
Okay, 14 wants us to find the altitude. So what is the altitude?
It's the height.
Okay, so directly down. It tells us angle A is 52 degrees. How big would angle C be? Right. If these two are both equal size, then the angles opposite those have to be equal angles. Just like I always tell you, the bigger the size, the bigger the opposite angle. Equal sides, so equal opposite angles. And then if you know that this is 4 inches, all of this is 4 inches. By the way, how do I know this is 4 and not this and this? Right, side B is always opposite angle B. So this whole thing is 4. Do you see how this is cutting this in half? So each of these is 2. Well, then you can just focus on one of your right triangles. You've got 2 of them to pick from. And from 52 degrees, you're trying to find the opposite when you know the adjacent. So that would be tangent, because tangent is opposite over adjacent. And then assuming your calculator is in degree mode, that should be enough, about 2.560. Did somebody have anything more specific about 14? Okay, these are good questions. You got any others up through 15? I did not ask you to go past 15 yet, so. Okay, the good news is after 15, we don't have a lot of questions here, so we can really take some time on each of these. Some of these are pretty easy and some of these are a little more complicated. But 16, 17, 18, 19, 20, 1, 2, 23. That's like 8 questions that we need to worry about. But again, some of these are more involved than others. But if I just go over each of these, they're going to seem easier than they should be. Starting with 16. So with each of these, I want to give you a few minutes to try it yourself so that you can practice making your picture, start to think about what the process should be. Some of them I'll give you more time on than others, but you really need to try them to see where you get stumped, because that's going to highlight for you what it is that you need to study. So let's say question 16 here. Let me give you about 4 minutes. So in 4 minutes, try to set up the picture, see if you can figure out what they're wanting you to do, and see if you can get the height of the flagpole. And then we'll talk about it as a group.
Can I get another copy? My paper got all wet, and I think it will rip if I check it.
Do you see the basket over there that says pre-cal handouts? Yeah, it should be at the back. It's organized by binder number. So done with that one?
I'm a little bit confused. To the top of the flagpole, 28 degrees.
So where's the flagpole? So this is the flagpole.
To the base of the flagpole, it's 28 degrees. So
Oh, okay.
there's the flagpole.
Does this mean
Oh, I got it. That's the base of the flagpole.
so okay, so here's the flagpole.
That's the top of the flagpole. Still got it.
Again, just do what you can, and after a few minutes, you're going to know that you either understand this type or where you're going to need some assistance.
So the angled elevation.
75 degrees.
Sorry,
It's like, so it's on here. It's on
Wait, Jacob, so where'd you get 28 here?
28 is the base.
What's this one up here?
That's the top, that's the tip.
So this is 39.
I don't see library, I don't see a flagpole.
Oh, I see. From here.
I mean, I can't tell you if you're labeling your stuff right if I don't know what you think of the library.
So then we have to find the height of this right here.
All of that together.
Exactly. So we do use Sokotoa, Toa.
Oh, wait.
The flagpole is mounted on the front of the library's roof.
So let's
So we do 10
so it's
23.
Of course, if you're absolutely stuck on 16 and you're just waiting for us to go over it, just move on to 17 and start getting some of it done. Likewise, if you think you got number 16 correct, you can check your answer with the website, move on at your own pace, or you can wait till we go over it and you can do it correctly.
Is equal to X.
But you should also move on.
Jason over on height.
this all together is 13.75. Then do that minus 14. So wait.
So there's 100 times 10 is 28.
What is this?
This side.
Do you know how we got that?
53.
Yeah, we added that. Okay. It's saying the base of the life to the base of the
Okay, one more minute and then finished or not.
Cosine.
This
No.
is 39. So, this is that, so add 90 plus
39.75.
and then it just goes
83 on the height of the flag.
so 180 minus that. Okay, so
One,
we didn't need that, but.
6.
Oh, that's the height of the library.
So exactly, so then you do subtract.
Okay, time's up. All right, so unless you have finished 16, checked your answer online and know that it's correct, at this point you need to follow along with me with your guys' input so that we can see where you got stuck, what you may have assumed incorrectly, and what you need to do. Okay, I'm going to start it off here, and some of it, you guys had some triangles drawn and you asked me if it was drawn correctly. But then you don't, like, I don't know if you know which part of it's the flagpole, which part of it you think is the library. Like, I know it seems kind of silly to actually draw a library and a flagpole, but I can't tell you if your stuff's set up correctly if I don't know what part you think is what part. But it said the flagpole is mounted on the top, on the front of the library's roof. So library, the flagpole is up there. They gave you two angles. The angle to the bottom of the flagpole is 28 degrees, and the angle to the top of the flagpole is 39 degrees, 45 minutes. So just like one of the homework questions a minute ago, you really need to change that to a decimal. That's the same as 39.75. Okay, there should be no secret in each of these questions that you should have a right triangle, because we have only done what's considered right triangle trig. Pythagorean theorem's great, but it only works on right triangles. SOHCAHTOA is great for finding side lengths, but it only works on right triangles. Inverse SOHCAHTOA to find angles only works on right triangles. We don't do any non-right triangle trig until January, when we do law of sines, law of cosines. So, what did y'all do from here? This is what we're trying to find that's highlighted. Yeah, sure.
to tangent of.
Hey guys, y'all need to stop your conversations, please. If you need help with this, then please pay attention. Otherwise, hold off.
The tangent of the 39 degrees equals x over 100 to find the whole flagpole and building.
Okay, wait. So you did. Sounds like he's looking at this big right triangle. If you're using the big angle, and you did tangent, which would be opposite over adjacent. And actually, we knew that too, right? So the height of the library plus the flagpole is 100 tangent of 39.75. And I can type that in my calculator to get a decimal, but I'll just wait. Okay, how does that help me find the height of the flag? What's the rest of it?
You then subtract the 100 tangent of 28 degrees.
Okay, good. So then there's a smaller right triangle, this one that I did in red, and I'll call this H. So from 28, tangent of it would be opposite over adjacent. So the height of the library is this. But I still need to know what's the height of the flagpole. So how can I use those to find the height of the flagpole? Right. If all of this I called X, subtract this, that's not part of the flagpole, which I called H, then the difference of those is how you get the height of the flagpole. 29.998 feet. So if you can do a SOHCAHTOA equation to find one side, then you can do a SOHCAHTOA equation to find two side lengths. This particular question wanted to see if you understood why you needed to subtract those lengths. If you don't see why you need to subtract those lengths from your work, you need to work on your picture again. You may need to go back and try that picture sometime between now and Wednesday. But does that clear up where you got stuck, if you got stuck? Okay. Any other further questions about 16 while it's up? Okay. Then let me set another timer for number 17, but number 17 is not nearly as involved, so I'm not going to give you as much time there, just a couple minutes. And same thing, if you're willing to pull up the answers online, see that you got the answer correct, you can move on to 18 without us. Otherwise, you need to stick around and wait till we talk about it as a group. Okay, I'm cutting you off. So, finished or not, if you want to rejoin us for question 17, please. So once again, you should have a picture, and somewhere in your picture you need a right triangle so that you can do right triangle trig. You've got a 75-foot cell tower. It wants us to find the angle of elevation from a point 95 feet away. So you have to remember, angle of elevation is from a horizontal line measured up. So there's your right triangle. Here's the angle we're trying to find. So this is taking a concrete idea, concrete real world problem, and trying to represent it abstractly so that we can do it the same way we did the first 15 questions. So I don't know 2 of 3 angles to just subtract those from 180 to find the third one. So what was the only other way to find an angle? How did you find your angle in this question?
Using inverse tangent.
Okay, so why tangent?
Because you're getting the opposite and adjacent.
Okay, if you're given opposite and adjacent, it's still tangent. Why inverse tangent?
You find the angle.
Right, if you're finding an angle, it has to be an inverse function. So that's all that had to go in your calculator. And these don't tell us how to round, so I'm just going to round to 3 decimal places, since that's what we always ask to go. It's great to be able to subtract 2 angles from 180, but sometimes you don't have the information from that. Sometimes you have to do inverse SOHCAHTOA. Okay, anything else about this number? What's this, 15, 17? Anything else about number 17? Okay. Okay, for question 18, I'm going to give you a few minutes to read it and see if you fall into the common traps here. However, there is one thing you have to assume about question 18, which is bad because in math you should never assume anything. But they expect you to assume this, and they don't really give you much of a hint here. But this is what they're trying to get you to find. But this and this make a right angle. So they expect you to assume that, but then they don't really give you the information where you should be assuming that. So also, we just took these questions from your textbook. So if you actually go to your book, section 4.8, you'll find these same questions. But just did it for you in worksheet form. So take a couple minutes here for question 18, and I will quickly tell you the answer is not it is not 72.255 degrees. If you get that, you fell into the very common mistake, but we'll go over it in a few minutes. So just give everybody time to actually try it on their own first. Hey, Marley, you're marked as parent contact.
Yeah, I know.
Okay, well, I can't take it off, so if that bothers you, you'll have to tell the office.
Okay, it's fine.
tried to make that was the 72, but maybe not.
Okay, let's give everybody one more minute. Again, you're welcome to move ahead. But I can see some of you guys are falling into that trap, so. Okay, for number 18, I'm getting an answer of 76.373. So if you didn't get that, it's probably going to be an easy fix, but this is what you were trying to find. You need to realize that these two are complements. So if you can find this angle of the triangle, you could subtract that from 90 and get your answer. Everybody okay with that? So then it came down to trying to find this angle of the triangle. How did you guys go about finding out how big this angle is? How did you find out how big this angle is?
90 minus arc sine.
Okay, so I'm going to do the 90 minus later, just this part. So inverse sine of what?
16,500 or 4,000 over 16,500.
Okay, tangent is opposite over adjacent, or not inverse tangent, I'm sorry. Inverse sine, because we have opposite and hypotenuse. How big is the hypotenuse? 16,500. It is not 12,500. 12,500 is from here to here. They make that very clear, but typically students just glance at that and move on too quickly. So how am I supposed to know how big the whole thing is? Right, if the radius is 4,000, then the radius is 4,000, no matter which direction. That's why it was 16,500 for the hypotenuse. That's the part, this plus this. That's the part that I was concerned about y'all doing incorrectly. Okay, and I'm wrong about this answer because I don't know why I was thinking inverse tangent. This ends up being about 14.030. Sorry, the real answer should have been 75.970 degrees. So you may want to circle that or highlight that in case we put one of these question types on your quiz Wednesday or your test next week. Easy fix, but if you didn't do that on your own, then there's a good chance you're not going to do it when you see it on an assessment. Okay, does anybody need to ask anything else about 18? Okay, 19 is one of the quicker ones, so just a couple minutes to try 19. So please start that now if you haven't. I don't remember. Looks like most people are finished with 19, so let's do one more minute to get everybody back up to speed. Those of you that are doing well should start trying some of those questions on the back. Some of those are pretty tough. It'd be good for you to see that some of it's not going to be as easy as some of this other stuff. Okay, so the main thing there's one big thing with 19, and this is going to come up in the very next question as well. When you guys start to set up your picture here, you've got a runway, you've got an airplane taking off at 18-degree climb. His speed is 275 feet per second, and then they want you to find the plane's altitude, which would be how far away it is from the ground. So there's the right triangle. And they want you to find that after 1 minute. So actually there's two things I'm concerned about here. One is this 275 is in feet per second, whereas this is in minutes. You don't want the units to mismatch. If this is in seconds and this is in minutes, that's going to cause you problems. So I'm going to change this to, doesn't matter, I'll change this one to 60 seconds. The other problem is, and this is a big one, when I answer this altitude, should my answer be a time, a speed, or what? Should be a distance, so something in feet. If I want this to be a distance, I need these to be a distance as well. If you treat this as if you just leave this 275, which is his speed, then you're going to think his altitude is next to nothing. You're going to think this plane is still near the ground, because this is the hypotenuse, so this side has to be less than that. The plane's definitely higher than 275 feet after 1 minute. Especially at 18 degrees. 18 degrees sounds pretty steep to me, but I don't know. So this is where the time comes into play. If you're doing this many feet per second for 60 seconds, then don't think of this as 275. Think of it as 275 feet per second for 60 seconds. This is 16,500 feet. Now that this is in a distance, when I do a SOHCAHTOA equation, this will be in a distance, which is what I want, a distance or a length. So finally, the sine from that acute angle is opposite over hypotenuse. So your answer should have come from 16,500 times the sine of 18, which is about 5,000 98 feet, 0.780. If something really threw you off on this question, again, I think it boils down to this. Every side needs to be consistent. If you want this to be a length or a distance, you need this to be a distance as well. They gave it to you as a speed. That fast, or that many feet per second for 60 seconds, because it was 1 minute. That's where I got the 16,500. This should be your final answer. Okay, you guys okay with that? Anything else you're still not sure about? Okay, then for number 20, I need to tell you a couple things here. This stuff, some of this stuff just doesn't matter, and that's why I need to just make sure that you're not focused on the wrong things here. But a nautical mile is like a mile in the water. It's not exactly the same thing as 1 mile on land. It's like 1.018 or something. You don't need to know that unit conversion. That doesn't matter. Just pretend like it's regular miles. Likewise, when it says 20 knots, that's basically like 20 miles per hour. It's not exactly 20 miles per hour, but you can treat it like 20 miles per hour. So just pretend like this says mile and pretend like this is 20 miles per hour. Knots are just like a speed in water. Again, it's not exactly 1 mile per hour for 1 knot, but that's not the concern here. The other thing is, this is the first one that has a bearing. You're going to have to take a bearing south 29 degrees west. So you probably saw bearings for the first time last class. So at the top of your page, it might be a good quick reminder that a north 30 degrees east bearing would start at the north line and turn 30 degrees towards east. An east 20 degrees south bearing would mean you would start at the east line and measure 20 degrees towards south. A south 45 degrees west bearing means you should start at the south line and turn 45 degrees towards west. And a west 15 degrees north bearing means starting from the west line, turn 15 degrees towards the north line. You've got to be able to read those bearings. That's the only 100% new thing in this section. So if you need to look back at your front page to help you make that picture, then please do. And then go ahead and try to finish the rest of 20.
It should be a 14. Okay. I don't know if I just wrote it sloppy or I don't know if I actually finished the question. I don't think I probably did.
But thanks for letting me know, because I'll re-record that.
You don't have your picture yet.
Okay, let's see if your picture looks good and see if you got what you needed out of this. Okay, so my top concern on this question would be the bearing, because I know that's what's new. So that's certainly something I would suggest you review before Wednesday's quiz, even if it's just for 30 seconds. But your ship leaves port at noon, taking this bearing. So from somewhere we've got a port, and then starting from a south line, turn 29 degrees towards the west line. So they're taking that direction where this is 29 degrees. That's what that bearing means. To finish your picture, this guy's going 20 knots, which is like 20 miles per hour basically. And you are trying to figure out how far south. Here's my ship. How far south we have traveled and how far west we have traveled, which that creates your right triangle that's needed. Now, similar to the last question, this length is not 20. 20 knots is a speed. This is supposed to be a distance. This is supposed to be a distance. Then this needs to be a distance. So if you're leaving at noon at 6 p.m., so 20 knots for 6 hours, that's 120 nautical miles. You could just say miles. You have to change that to a distance or a length. That's all the important parts, because now we can get the two lengths just like you did questions 1 through 15. You could do a sine equation if you want opposite over hypotenuse. So the amount of distance that you traveled going west would be 120 times the sine of 29 degrees. Which is about 58.177 nautical miles. And if you want to know the distance south that you traveled from 29 degrees, you're trying to find adjacent when you know hypotenuse, so that would be cosine. So the distance south that you're traveling ends up being 120 times the cosine of 29, or 104.954 nautical miles. So at the end, two SOHCAHTOA equations to find two sides of a right triangle, but setting up your right triangle required us to be able to read this bearing and the wherewithal to know that this needs, if you want these as lengths, you need to change this to a length. Don't leave this as 20, it has to be 120. It's 20 knots for 6 hours. Noon to 6 p.m. is 6 hours. 20 times 6 is 120. Okay, is that enough on this one? Everybody made their corrections? One thing I like about this question too, although I'm sure y'all don't necessarily appreciate it, this south answer came from 120 times the cosine of 29, and the west answer came from 120 times the sine of 29. So one different trig function. I mean, it's almost the identical thing that we typed in our calculator, but we're measuring very different things. So, very useful. Okay, number 21, we got 3 left. 21 and 22 I think are the two hardest though. 21 is going to require us to use some bearings again, and this one takes a little bit more thought than some of the other ones do. So likewise, I want you to go ahead and try to add some of that information to the picture. Try to think about what it is you need to find to get the answers. This has 2 parts, an A and a B. Part A is not too bad, part B is a little bit harder, but you need to see if you already know how to do this. So go ahead and try it. I probably won't give you time to finish it, because after about 5 or 6 minutes, most people are going to be stuck, so that's okay. about 4 more minutes before.
I assume everybody's finished their stuff.
I think I figured out this one.
That's where they got Yeah, 54 minutes. Do not describe the junk at all. They're all out of the art summary. It's literally like.
Wait, no. Wait, no. I invented this. I remember inventing this when I was in 5th grade. I was like 9.
Is that your one?
Oh.
You think so?
That's the, well, that's really cool, but like, I think
It's already over there.
wait, did some magic.
Oh, okay. All right, sorry about that. Okay, let's go over this 21 to clear up anything that you needed help on. Okay, so the first part of this question, you certainly do need to know these bearings and how to add this to your picture. So the bearing from A to B, so if you were standing in A and you wanted directions to head towards B, you should take north 30 degrees west. So that doesn't mean that this angle is supposed to be 32. In fact, it's got a right angle there. We know it's a right angle. But from the north line, straight up and down north, you have to turn 32 degrees to the left because that's the direction of west. So that bearing is supposed to fit in right there. Now, at first it's kind of weird that they even gave you that, but you'll see that you do need it here in a bit. The other bearing they give us is from C to B. So if I was standing on point C and I wanted directions to head towards point B, I could start at the north line and turn 68 degrees towards the west line. So if you can't read those bearings to add those two angles to your question, then you won't be able to do this type for us. Okay, part A is not too bad because if you got those down, it wants you to come up with a bearing from A to C. So standing in A, I'd like to head towards C. So we could go from the north line, turn right, which would be towards the east line. And how much are we supposed to turn here?
58.
Good. If this whole thing is 90, and then they indirectly told us this part of it's 32, then this part must be 58. Everybody okay with that? So not too bad if you can read and write a bearing. But part B, I'm going to go about this in kind of an indirect way because I think it helps you see what you need to find. There's lots of stuff about this problem you could find, but it's not asking us to solve this triangle, so we don't want to have to find more than we need. But if I would like to know the distance from A to B, that's a side of a right triangle, we instantly know we've got two ways to do that. Pythagorean theorem, if I know two other sides, but finding this length would be just as much work as finding this length, so Pythagorean theorem is probably not a good idea. Or what's the other way to find a side? Okay, so SOHCAHTOA, something SOHCAHTOA. But for a SOHCAHTOA equation, you need to include the side you're trying to find. You need to pair it up with the side you know the length of. And you also need one of the acute angles. Now, I don't know how big angle B is, and I don't know anything that's going on here. But if I can figure out how big angle C is, if I can figure out how big angle C is, I could say the tangent of that is equal to opposite, which is what I'm trying to find, over adjacent, which I know. So my final answer is going to come from 50 times the tangent of angle C. So now I at least know I have to figure out how big this angle C is. That helps me narrow. I'm kind of backtracking. I'm thinking about what am I trying to find, what type of information do I need, so that helps me narrow down to what I still need to find. If I can figure out how big side C or angle C is, I can figure out how long this distance is. Now, this is the part that I'm concerned about because we have not needed this for any other trick, and you had no hint for me, because you wouldn't have this hint for me on quiz day, except from last class when I squeezed this into our notes at the top. Sometimes when you need more angles, and you can try with that picture that we had up there, you can try as much as you want to, you just don't have enough angle information. But if you can find two parallel lines cut by a transversal, any of these angle relationships you used in geometry are welcome to be used here. I'm going to refer to alternate interior angles. So on my picture here, somewhere. Okay, do I have two parallel lines in this picture? What are they? Okay, so what I would call, remember how this was a north line and this was a north line? We use those as part of the bearings. Well, a north line and a north line are going to be parallel. So you could think of this as the transversal. Now, I know this is kind of tilted. You guys get spoiled in geometry where it's always written like this. Two parallel lines cut by a transversal, angles that alternate in the interior, like angle 1 and 2 here, have to be congruent. So this angle C is in the, oh, I'm not doing that angle yet, but this 68, the 68 is in the top right of the transversal in the inside. So he's going to alternate with the bottom left of the interior. This and this is one possibility that you can move forward on. These two are alternate interior angles. Again, I can't turn my paper up on the screen here, but parallel line, parallel line, parallel line, parallel line, top right alternates with bottom left. Alternate interior angles are congruent when that is the same. And then finally, that helps because now within this triangle, I know 2 of 3 angles. So the last angle will be what I add to 68 and 58 to get 180. Which is 54. And then that was the last domino to follow before I get my answer. 68.819 meters. Okay, so you need to make sure that you can label some of these bearings to get a couple angles, but when you know you need more angles and you can't just do inverse SOHCAHTOA because you don't have a right triangle and 2 sides, and you don't have 2 angles of a triangle to just subtract those from 180, it's probably that you need alternate interior angles. Now, it's not that our quiz is going to have 5 of these questions on there, but you should expect at least 1 or 2. So, the fact that these were alternate interiors, how I knew this was 68, I used these 2, subtract from 180 to find this, and then once I had this, I had enough information to finish my SOHCAHTOA equation. So, a lot going on there. Is there anything specific you want to address? Anybody get that far without any hints? Couple? Okay, good job. Okay, the very last question's not too bad, but 22 is probably about the same difficulty as 21. So if you have not tried 22, give it a couple minutes to see what you think you should do, and then we'll make sure that you're on the right track here. I'm not going to give you quite as long here because it's a little easier to get stuck on this one. All right, so this question does give a couple bearings, but they did put these in the picture for us, so that shouldn't have held you back. Ultimately, we need to figure out this distance, D. I'm guessing this is like a road, so the distance from the road to the fire is probably what they're describing. And to move forward on this question, you had to realize that you have two right triangles. You've got a right triangle right here and a right triangle right here. So you can start a SOHCAHTOA equation from this one. You could say from 14 degrees, I know the opposite is D, and I know something about the adjacent, so that would be tangent. Tangent is opposite over adjacent. But this length is not 30. The whole thing is 30. So since I don't know this length, I'm going to label it as X. And unfortunately, if I have an equation with two unknowns in it, I can't solve this for D. I can't have two missing pieces. It depends on what X is. But if I can figure out what X is, multiply both sides by X, my final answer is going to be X times the tangent of 14. So I'll leave the little blank there so I don't forget to come back and do that. Then I can do the same thing with this right triangle. From 34 degrees, the opposite is D. I know something about his adjacent, so that's going to be tangent again. What would you call this length?
30 minus X.
Good. So you could call it Y. This is X. I didn't know it, so I labeled it X. I also don't know this length, so you might be tempted to call it Y. But it's a lot better to say if this whole thing is 30, if this much of it has already been called X, then this much of it would be called 30 minus X. The problem with this one is it also has two variables. You can't solve an equation that has more variables than what you have. But now we have two equations and two unknowns. This is called a system of equations. And you have to be able to solve a system of equations in calculus. Not often, but 4 or 5 times throughout the year. So, even as far back as Algebra 1, you did something called the addition method or the elimination method, which doesn't help too much in higher mathematics. You also learned how to solve these with graphing. Also doesn't really apply too much here. Did y'all do matrices in Algebra 2 last year? Add, subtract, multiply matrices? You remember doing that stuff? Okay. You can also solve these with your calculator in matrices, but if you don't know that, you don't know that. The one method that works all the time, and what we use most of the time in higher mathematics, is substitution. So I could take this equation, solve it for x or d, and then do substitution number 1. So instead of saying d, I could say x times the tangent of 14. And you need to understand why each one of these steps is going to be an improvement, because we're going to have like 6 algebra steps here. I made this substitution because this is not going to be fun to solve, but it's significantly better because it only has x's on it. So in theory, after a couple algebra steps of solving this for x, I can then plug that in over here and get the answer I actually want. Now, to solve this for x, again, you've seen all of these algebra things before, but rarely do you guys have to do this many algebra steps per question. But again, this is pretty common in calculus, so if that's what y'all are building up to, then you got to work your way up to feeling comfortable with this. But I would start off by multiplying both sides by 30 minus x. Why do you think I consider that an improvement over this? How does that help us solve for x? Well, what does this equation have that this equation doesn't have? Good. This one's got fractions, this one doesn't have fractions. That's why I chose to do that. I think that's an improvement. Remember, tangent of 34 is just a number, so the next thing I want to do is I want to get rid of these parentheses. So we could distribute. And this question is going to look kind of messy. It's going to look harder than it is. But multiplied both sides by the denominator, so I didn't have fractions. I distributed, so I didn't have parentheses. Then, like any other time you're trying to solve for x, you want all the x stuff on one side. So this is already on the right side. I'm going to add this guy over, so he's on the right side. 30 times the tangent of 34 degrees is just a number, so I'm leaving it on the left side. Now, I don't know. I always struggle with why you guys have trouble seeing this, but even calculus students have trouble with this as too. So it's one of the easiest algebra things you've ever learned, and when you're shown it, you probably feel like you have mastered it after 30 seconds, but usually you guys don't see what to do when you actually need it. Any idea what I can do to the right side if I'm trying to solve for x? What do you think?
You can GCF the x.
Very good. GCF. This guy has an x. This guy has an x. You can factor out an x. You can factor out a GCF. I know you can all factor out a GCF, but you've also got to see that you can do that when you need it. And then finally, to undo times this big number, we can undo that by dividing. So now I can ask my calculator, what is 30 tangent of 34 over tangent of 14 plus tangent of 37, or 34? That's about 21.904. Is that miles, kilometers? And if you're not careful, you're going to think that's your answer. especially after you put that much time into it. Usually putting that much time into it, that would mean that's your answer. This question could care less what the distance x was, but what it did want you to find was d, and d is x times the tangent of 14. 5.461 kilometers, approximately. So, SOHCAHTOA equation from the left right triangle, SOHCAHTOA equation from the right triangle, two equations, two unknowns. We solved it with the system of equations. So the 32nd algebra of that, you have to solve one of them for d or x. I solved this one for d in terms of x, substituted that in here, so then I had an equation that only had x's in it. Again, it took several algebra steps, but no algebra steps you guys have never seen before. I multiplied both sides by the denominator so I didn't have a fraction. I distributed this number so I didn't have parentheses. I put all the x's on one side, just like every time you solve an equation. Both of these have an x, you can factor out an x, and then undo times with divide. Threw all this in the calculator to get x, and then once I knew how big x was, I multiplied it by the tangent of 14 to figure out what d was. So, pretty challenging algebra question, but again, individually those steps are all things that you guys have done. So before we move on, any of those steps that don't seem intuitive to you, you probably need to put some words in here. If it wasn't intuitive how I went from here to here, you probably need to write multiplied by the denominator to get rid of the fractions. If you're not sure, if you don't think you're going to remember how we went from here to here, you might say distributed tangent of 34 to get rid of parentheses. If you don't remember why, if you don't think you're going to remember why we moved this over, you probably need to say something now. If you don't think you're going to remember factoring out a GCF, write it in words on your paper so that you remember. But take a minute to recap that, and of course if y'all have a specific, go ahead and speak up. And then after a minute, go ahead and try the last question for us to go over, and then I will remind you of what you need to do between now and Wednesday and make sure that you're on track. You finished? Cool. You checked your answer to the last one? Okay. So. What you got?
How did you get the 21.904 from? Like, how did you get the x from?
How did I get what part?
X. Like, not all of it, but like, did you do 30 divided by tangent of 14 to get that?
I divided both sides by tangent of 14 plus the tangent of 34.
Oh, then you have to write all of that out, like, completely.
I mean, that's where it came from.
So you can't, like, divide tangent 34 by tangent 34 right there, like, you can't cancel those out?
These two?
Yeah.
No, you can't cancel out terms, things being added
Oh,
or
they're
subtracted.
added, okay.
Yeah. And at that point, you have a calculator anyway, so why run the risk of canceling those? Just throw it all in the calculator and get it done. Also, I know you guys don't really probably like questions that have this much algebra. Not to try to scare you out of calculus or anything, but we do a lot. By far, the hardest part of calculus is algebra. And so I was just pulling up some of our notes we've done recently. And so in calculus, like this first step had some calculus that you wouldn't understand or know why it works. But distributing negatives to get rid of parentheses, putting everything on one side that is a certain type, factoring out GCFs, just like you guys did on that question, and doing times with divide. This algebra is sounding a lot like the same type of algebra as that. Likewise, things like factoring, points, equation of lines, slope formula, all of this was for one free response, and actually it wasn't even the whole thing. Here's another part of it. All of this is one part of an FRQ, second part of an FRQ, and third part of an FRQ. Calculus takes a lot of algebra, so I'm not saying you have to think that this algebra is easy, but if you know that you're pursuing a career in math or science and you're going to need calculus, then you need to not be dismissive of these algebra steps. This stuff is important. Okay, was there any other questions to finish up 22? Okay, 23. Did everybody finish 23 or get stuck? Are we good to go over it? Okay. All right, the biggest mistake that I have seen on 23 in the past is you've got a ship 45 miles east, 30 miles south of port. So if you do this, here's my port. The ship is 45 miles east, and then 30 miles south. Here's the ship. It's very easy if you don't label these points to accidentally put your ship here and your port there, which is important if you're trying to give directions like a bearing. The directions you would give from your house to school are different than the directions you would give from school to your house. It makes a difference which one's the port and which one's the ship. But you want to go from the ship to the port. You've got a right triangle. So finding this angle in here is what you've been doing since geometry. You could do inverse tangent of opposite over adjacent to know that angle is about 56.310 degrees. But that can't be your final answer because that's not a bearing. You can't tell someone, directions to Walmart, go 56 degrees. That doesn't mean anything to anybody. But you could say from the north line, turn 56.310 degrees towards the, if I want to go towards the left, that's towards the west. That would be an acceptable answer. Or, and I don't know why students do this sometimes, but I'm going to throw it out there just in case this makes more sense to you. But sometimes people draw in an east line. They figure out this angle. It would be the complement. It's 33.690 degrees. And some people prefer to say, starting at the west line, turn 33.690 degrees to up, which would be towards the north line. And that's acceptable too. I don't know why you would do that because that requires some extra work. But both of those are perfectly fine. Okay. You guys okay with 23? Anything before we finalize class? Okay, so again, good idea to put in your planner about our 4.8 quiz at the start of class on Wednesday. About half of the quiz will be what you did last class and for homework, just generic triangles, find sides, find angles. And about half of your quiz comes from word questions like these. So there's a chance there could be one like this where you had to subtract 2 links, ones like this where you have to do inverse SOHCAHTOA and you draw the pictures, ones like this where you might not be careful about the hypotenuse length, ones like these where you need to make sure the sides are linked so that your answers are linked, some of them that use bearings, some of them that use alternate interior angles, some of them where you have to solve a system of equations, some of them where you write a bearing, but all of the quiz questions will be similar skills to what's on here. So about half of it, 1 through 15, about half of it, the other ones.
Is it gonna be this long?
No, it won't be this long. No. It's just a couple of each, but I need you to be prepared for all of them. Okay, additionally, the only assignment I gave you guys in section 4.8 is this. So this is the one thing you need to turn in. I don't know how you wouldn't have it finished between me giving you a chance to ask questions from 1 through 15 and us talking about all the others together. But you need to make sure you have that turned in for those homework points. And also don't forget, this is the second half of this unit. So we've got our 4.8 quiz next class. And then after that, we will be moving on to test review stuff because your next test is only over 2 sections.